Hey everybody, Mr. Field here, and today we're going to be talking about how we can apply our knowledge of trigonometric ratios and actually apply them on the coordinate plane itself. All right, so a little intro here, a couple examples for you to try after I'm done going through a few. Let's start with the first one. So what it's going to ask you to do first and foremost is I want you to graph the point. In this case, looks like -6, comma 8 on the coordinate plane. From there, it wants us to actually apply what we know about SOHCAHTOA in order to solve for the 6 different trigonometric ratios, sine, cosine, tangent, and of course their reciprocals. But before we do that, a little bit of terminology and background info. So first and foremost, we know that every coordinate is an x comma y value, where x controls left and right, y controls up and down. So if I was to provide a written explanation to someone how to plot this point, notice we have x is -6, which tells me since x controls the horizontal direction, left and right, from the origin here, where I'm highlighting in purple, I'm going to have to go left 6, pardon, and then since the y value 8 is positive when y controls up and down, I'm going to have to go up to this point here, 8. So I have two values. I have a x or horizontal distance of -6, and then I have an up value, a height of 8. So that's typically where you're going to start. You're simply just going to plot this point. The next thing you're going to do is you're going to create a right triangle. So you can drop an altitude. Typically, you start by just plotting that point. We drop an altitude, which again means height, giving us this right triangle here in the corner. And then, of course, we can draw what we call the terminal side of this angle. All right. Some of the terminology we're going to talk about is the initial side, which let me get a different color. Typically, you start with an initial side, then this thing's going to rotate, tick, 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 ding, and then stop at that point, creating this angle theta right here. This side that I'm highlighting now in yellow would then be the terminal side. All right. The difference between the initial side in blue, the terminal side, is that rotation theta. That becomes what we call our reference angle, and a reference angle in the coordinate plane will always have a vertex at the origin. So that's important to know. So again, step one, just plot your point. Step two, you're going to create a right triangle by dropping an altitude and by drawing what we call the terminal side, which also becomes the hypotenuse of your right triangle, giving us reference angle theta. Now, at the moment, we don't know what that angle is, but of course, we could use Trig to find it. But then again, that's not necessarily the point of this video. So that's a little bit of background, plotting points, terminal side, and this thing called the reference angle, or theta, the one we're referring to, which again will always be at the origin. Long story short, we know we have a right triangle. So that opens up the world of possibilities for maybe we can use Pythagorean theorem. Maybe it's a special right triangle, which we're not going to get into in this video, but we'll definitely be talking about this thing called angles in standard position, or with those special angle relationships, those 45, 45, 90, or 30, 60 right triangles next week. For now, we're just going to start with plotting points in the coordinate plane and applying SOHCAHTOA. So that being said, obviously we have a right triangle. As you can see, we didn't know what the hypotenuse length was in this case, which I'm calling R, which I'll talk about why we call it R in a little bit. But we did know that we knew that, for instance, that this value I could call maybe A, this I could call B, then of course using Pythagorean theorem, A squared plus B squared equals C squared, or in this case R. That's how I solved and found the hypotenuse length. And once I have all three sides, then I can simply use my theta, its location. I can label, for instance, opposite, adjacent, hypotenuse, and then we're in business. Now we can actually apply the trigonometric ratios, sine, cosine, and tangent, and the reciprocals to actually answer the question, like what is the sine of this mystery angle? What is the cosine? And so on and so forth. The most important thing to remember before we do that, though, is we've got some new labels going on. So let me get a different color so it's pretty obvious. Remember, when we went back to this point, notice x was -6, y was +8. So another way of calling the adjacent side in this triangle, we could refer to it as x, right? The x, the distance from the origin to the left at this point right here. That's also the adjacent side. We can now call it x. The opposite side looks to me like it's a height, so that would be a value of y. Then, of course, r, that important piece of information, that stands for the radius of a circle. Now, I don't want to get too complicated, but in the next section, we're going to start talking about this thing called the unit circle. We're going to talk about circles and angles and the special angles in the coordinate plane. So it's important to realize that r, or the c value, the hypotenuse, is really just representing the radius of the circle. Because remember, if we were to continue this path all the way around, it would create a circle with, in this case, a radius of 10 units. But we don't know that just yet, so let's not get too far ahead. All right, so long story short, the most important thing to remember is I referenced it over here. Sine we know is the opposite side over the hypotenuse. Well, looking at the picture, the opposite side looks to be a height. That's why I labeled it y, and the hypotenuse is now labeled r, or the radius of this circle. So therefore, we can convert sine from O over h to really y over r. And that would make cosine, remember, cosine is adjacent over hypotenuse, well, this side over the hypotenuse, that would make it x over r. And finally, tangent, instead of being opposite over adjacent, could now be considered in the coordinate plane y over x. So this is just a little reference sheet that we're going to be giving you and that you'll be able to use during assessments. But it's important to know that now we're changing from just opposite over hypotenuse. Now we're switching to x, y's, and r's, and we can use that to answer these questions. Finally, a lot of background information just talked about. Let's get down to business and actually finish this first problem. So we're asking for the sine of this theta, this angle, should be opposite of our hypotenuse, which we also now know is y over r. Looks like the height is 8, and looks like the x value, right, is 6. Now we have to be really careful here because technically, ooh, did I make a mistake? Yes, I did. I'm being silly. Sorry, the opposite, excuse me, over hypotenuse. Sorry, this would be 8 over 10. Pardon me. Now, of course, if you can reduce, you typically should, but for the limited time I have in this video, we're not going to reduce these fractions. Keep in mind, the sine and cosecant are the flip of each other, so I can just reverse that and make it 8 over 10 turn into 10 over 8. So we're about a third of the way done. Let's talk about cosine. So cosine is supposed to be adjacent over hypotenuse, which we know is now x over r. So we can just say negative 6 over 10. And of course, the flip of that would be 10 over negative 6. Keep in mind, technically, you should be reducing these fractions. Another important thing to note is because now that we're in the coordinate plane, anytime you have a value for x, for instance, that's negative, well, that means you went to the left. You're either hanging out in the second or the third quadrant, which is really important to make sure you remember. We're not just going to have all positive numbers now. The same thing goes for y, which I think we're about to encounter. So notice under tangent of theta, it's supposed to be opposite over adjacent. Well, it's supposed to be 8 over negative 6 in this case. Notice we have a negative answer as well, and the cotangent should be the flip of that, negative 6 over 8. Just be careful for where x is negative and where y is negative as we're plotting these points. So example 1. Now, I did a lot of talking there, a lot of mumbo jumbo, so let's do one a little more straightforward and kind of like start from the beginning. So as you can see, I drew this triangle, I plotted the point, x is left 5, so I went 1, 2, 3, 4, 5 to the left, and then I went down, because I snuck that negative in there, root 11, which is, a little more than 3 point something, but in this case, we're just going to write down 1, 2, 3 and a little bit, so we're going to estimate. Of course, you can use your calculator to do that as well. So this is the initial point that we plotted. This line here is that terminal side, and of course that creates our reference angle, theta here. So from there, we can label this side opposite because it's straight across, so this would be adjacent, and this would be our hypotenuse. Keep in mind, I had to use Pythagorean theorem to actually solve for this, doing negative 5 squared plus negative root 11 squared, notice it's inside the parentheses, equals c squared, or in this case, we're going to start calling it r, because it stands for the radius of the circle. So r squared. Well, when you square a square root, it cancels out the root, so you're just going to get 11 plus 25. So r squared ends up equaling 36. I square root it. That's where that magical 6 came from. So you're going to have to do that legwork yourself. From there, we can start actually answering the questions, right? We know that sine, again, is supposed to be opposite over hypotenuse, which we've now converted. Notice opposite is a value of y in this case, right? Because it's going down, which is also going to make our answer negative. And then it's going to be opposite over hypotenuse, and also, in other words, we can call it, in this case, it's going to be y over r. So given that we had that, it's going to be, in this case, also known as y over r. Again, I'm just writing this for your reference. The final answer is going to be negative root 11 over 6 in this case, since we can't reduce that. The flip of that would be 6 over negative root 11. That'd be the reciprocal. So again, this would be r over y in this case, or hypotenuse over opposite, however you want to think about it. But I want to challenge you to start getting more comfortable with referring to x's, y's, and r's now that we're in the coordinate plane. So in this case, I'm cool, by the way, with you not rationalizing the denominator. Some teachers make you rationalize that, but we're cool in this section for leaving it as root 11 on the bottom of the fraction. That's fine with me. Let's talk about cosine. Now cosine is supposed to be a over h. So ka tela, that's the a over h. So in this case, I'm thinking technically a is an x value, right? It's a distance from left to right. So it should be really x over r, which in the end is going to be -5 over 6. If we flip that, we should get 6 over -5 for secant, because that's the reciprocal of cosine. And last but not least, tangent originally was O over A, OA. Now we're going to change that to opposite, which is y over A adjacent, which is x, distance from left to right on the coordinate plane. But long story short, what you really care about is the actual numbers. So I'm thinking O over A is going to be -√11 over -5, which actually changes it to +√11 over 5. And the same thing is going to come true for cotangent. So we simply have to flip our answer and get 5 over √11. And again, you can leave it in that form. I'm not uncomfortable with you you don't have to, my pardon, rationalize the denominator. All right. So what I'd like you to do is take a moment, give yourself a chance, pause the video, draw this triangle in the coordinate plane, and see if you can actually plot that point. And we'll end with one last question. Okay, hopefully you got a chance to actually try that problem. We're actually going to skip down again from because of time here. I don't want the video to go too long. And let's talk about example 3, which as you can see, I kind of already started. So this is given the sine of theta, which by the way, sine we know is O over H. And technically it's telling us it's in quadrant 4. Remember the quadrants go 1, 2, they go counterclockwise, 3, and 4. And this little reference above is telling you where x and y are negative. Just a quick reminder. Remember, they call quadrant 1 the real world where everything's positive, right? And then we have, of course, x is negative, y is positive in the second quadrant. Both x and y are negative in the third quadrant. And then we have x is positive since you're moving to the right, y is negative since you're moving down. 4. Just a quick reference for you. So let's use that and the information they gave us to answer this question. So step 1, we're going to plot that point, right? We're going to go O over A. Remember, opposite is now y, or sine is now y over r. The hypotenuse is the radius of the circle. So we know when we plot this point, we're going to have to go down 5, and then we're going to have to go a hypotenuse length, this terminal side, it's going to have to be 13 long. So we have a right triangle. Keep in mind, first thing we should really do is find x, find this side here in this case. It's a little bit trickier of a problem because it's hard to graph the point without having the actual coordinates. So this time they're not giving us the coordinates is really the big difference. They're just giving us a puzzle piece, a couple puzzle pieces, and we have to put the puzzle together. So we know that we're going to have a down 5, we're going to have hypotenuse of 13. We know it's got to end up being a right triangle. So the question originally is, well, how far to the right do we have to go in the x value? So that's really what we're solving for. So we know since we're solving for x, we can do a squared plus b squared equals c squared, where the hypotenuse is always the longest side, the c value. In this case, you'll see I solved the square root of 144, where x is 12. And now that we have that information, all we got to do is put the numbers in. So remember, sine is supposed to be originally O over H, which is now y over r. So we know the sine is going to be the y value, the height, which in this case is -5, over the r value, which is 13, and the reciprocal will be just the flip of that, 13 over -5. The cosine is supposed to be the a over h, which we just found by using Pythagorean theorem. The x value is 12. So we have a over h, where adjacent is now replaced with x, hypotenuse with r in the coordinate plane. So we have 12 over 13. And of course, the flip of that would be 13 over 12. And finally, tangent originally was OA, O over A. So this time, O is going to be replaced by Y, and A is going to be replaced by X. So all we got to do is write the height, -5, over X, which is 12. And of course, the flip of that would be 12 over -5. So I hope this video was helpful. Now what you need to do is go into your practice, go to practice A, and start actually applying this new knowledge. Thanks for watching.